Hello, my name is Chad, at Metalhead Maker on most socials. I am an electronics engineer turned musician, or maybe a musician turned electronics engineer, whichever way you want to look at it. I am working tonight on a main board for this 3D printed guitar that I'm building. And this is a very highly complex build because I am doing all sorts of fun little electronics, LEDs. I'm doing motors to help tune the guitar and some expansion capabilities down the road. But mainly, I just want to get this thing working. I've already gone through the process of doing a few prototypes. The first one was a really crude one using just your typical prototyping board, and I had to manually solder all of that stuff. Moving on to a much more professional manufactured PCB or printed circuit board that I worked on for a little bit. I did find a lot of bugs in this first version, and I am now working on the third version of this, which is the same thing, only with all the bugs fixed, and hopefully some really cool stuff happening once I get all this connected. Last night, I was able to get a good portion of the components on that board, and I will show you that here in a moment, but I now need to finish up getting those components on and do the rest of the testing. So that is what we're doing tonight. I really hope we can get this done. I'm not super duper hopeful that it's going to happen, but we'll see. There's a lot still to be done, and we should probably get into it instead of just yammering. So let's take a look at the board. Okay, so what you're looking at right now is pretty much everything I did last night. All these components on here were not there. As a quick little refresher, here's what we started with last night, and here's where we are now. It's a little easier to see if I angle this so you can see the depth of all those components. So all those got added, and I lightly tested some of the power, and that did seem to work okay. So that's good progress, but I've got a lot left to do. So let's take a quick look at what left we have to add to the board. By the way, if you are stopping in, feel free to say hi. I am a little new to streaming, but I try to keep you guys at least updated on what I'm doing here and entertained to the point where it's not just me staring at a board and you waiting on me to say something awkwardly. So right now I'm going to just do some continuity tests. I need to make sure that on the board there's nothing funny that's going to come back to bite me later when I finally get the the microcontroller on. So what I expect to happen is that the continuity tests are going to show that I've got proper grounding to all the places that I expect. I've got proper power when I plug the power in, and there's nothing crisscross. So I don't want to be having a ground and a power, or a negative and a positive, showing that they're, you know, completely interconnected or they're completely connected. And if that happens, then I know I've got a problem or a bug on the board. So far, I mean, it was like 2 a.m. when I finished last night. What's going on, man? It's good to see you. This is hopefully the home stretch of the new board. And I just want to make sure that we have some basic continuity good, and then we're going to start adding the headers. And then and more headers. And then after that, we've got some terminals to add, and we can start plugging in some power. So let's just not screw around and get right into this. I'm gonna zoom this out just a little bit, since this is kind of, well, I guess that's as far as we're gonna get. This isn't too intricate right now. So I just want to make sure that I'm getting a good continuity on all of the grounds. I've got these little test points here. That hasn't changed from the previous board. Those are good testing when everything's put on, but I don't really need that because I've got so many options here for the various different sources for the signals. So here's a ground. I just basically want to go around and make sure that I am seeing 0 on the resistance. That means that I've got proper continuity. So yes, 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 expect that. Good. I have a shared ground across the entire board. Obviously shared ground, well, I shouldn't say obviously. The way this works is that a shared ground is going to be good for making sure that, you know, everything is going to be working on the same signal plane. And if you have something that is not grounded on the same grounding panel or the grounding plate, then you could deal with an issue where you've got what's called a floating ground, or some kind of issue where the signal just behaves erratically, and that's why we want to test this kind of stuff. Okay. So all the points that I'm testing now are the grounds. I was smart on this board, unlike the last board. Not totally smart because I didn't do it on every single header, but I labeled a lot more of them this time around, which makes it a lot easier. Yeah, that's not a ground, actually. What is that? Oh, it's D28. Good, good. Ground. We are looking good there. Gets a little more complicated as we move over to the power section. So basically from here on, all this is just power. Starting out with the input of the power, which is what's called a USB PD or power delivery. That is that USB-C port that you can plug into like one of those big bricks that can power not only something like your cell phone or a tablet, but it can also power like a laptop. So it can give you different kinds of voltage based on what that power delivery device requests. And this little IC here, or this little chip, is a CH224K IC, and this is what tells the power delivery what voltage that you need. So because of this, that gets really complicated to actually test continuity. We're bringing it into from the battery or from the power source into here, and then splitting that out to this, which then gives me the proper voltage, brings it over to the 5-volt rail here with the buck converter area. These are just a bunch of little components that make up a common design that allows you to step down the voltage from 12 volts to 5 volts, and then from there down to 3.3 volts. And that covers all the different types of voltages that I need on the board. So let's see, I think this is ground. See, this is where I did not label this bottom one, then that's going to give me some problems here. I think this is 12 volts. Nope, that is, I think this is 12 volts for power delivery, but not for the battery. So this right here is going to be the battery terminal that I haven't put on yet. Oh, where is that? I think it's right here. Nope. Where'd you go? Oh, yeah, 12 volt bus. I think this is the only test point I have. 12 volt bus means that this is what the voltage coming in from the USB specifically before it's been modified. So there we go. I mean, as far as I can tell, everything's looking good. I think we are good to start adding components. Even though I'm not putting power in, I just want to make sure that everything is as smooth as possible, because I have burned out way too many microcontrollers, as those of you who have seen any of my other videos on this project know. So I don't want to chance that again. So let's take a peek at what we have left to install. Okay, we've got, so obviously we've got to put the microcontroller and all of these on. We have our terminals. We have, these are a bunch of jumpers and I think I'll have to take a look to make sure, but yeah, so a bunch of resistors that allow me to use this expansion area here with either 5 volts or 3.3 volts, depending on which one that I jump or which one that I put a resistor on. So I'm purposely leaving those completely empty right now. And it's a bummer if you are here today and you weren't here last night, because last night I got to do the fun stuff where I did the whole layout of the solder, paste, and used this stencil and then reflowed everything and placed everything, and it kind of melts into place. That was really fun and it worked out really well. But there's a lot of this stuff that I have to think through before I actually put it on there. So, I need to spend some time kind of working through that. I've got the temperature sensor here that I got to install. I got to think through if I need to actually put any of these jumpers on here, because these jumpers are for the power delivery, to make sure that I have the right voltage selected, because you can actually select different types of voltages depending on which jumper you choose. Yeah. So over here, as you can see, this is the tape that I had all of my components on before I started yesterday, and I am down to almost nothing. Just got a couple things to install and a couple optional components. So that is that. Okay, probably good to start with the smaller components first. I'm going to actually hold off though on the temperature controller, or sorry, the temperature monitor. I am a little nervous about the wiring on that, because I had a bug on the first one. As you can see here, I had to jump that wire. You can see, yeah, there's a little pin here. I had to jump that wire because I had it totally wired up wrong. So let's just get going, I guess. Okay, I think I'm going to start, I'm just thinking, I think I'm going to start with the control board here. So basically I'm just going to put these two little headers on there, get some tape. Loosely get this on here. Well, maybe. Also, I'm hoping to not stream as long tonight as I did last night. I think I went for over 4 hours. Here, I just want to get as much done as possible, as quickly as possible, call it good, and then we can say we have some success. Or utter failure, depending on how it kind of plays out. Okay. Wait for my soldering iron to heat up. And I guess while that's heating up, I can go ahead and pre-prep for the other ones. There's a few that I'm probably going to skip right now, so I think I'm probably going to skip the analog expansion because I just don't need it yet. I am going to put the digital expansion on there, even though I'm not really using any of those yet. There's a good chance that I'll just want those for testing purposes in the early stages. Get on there. Okay, we'll tape that down. And the tape isn't really there to actually hold anything. It's just for the initial first pin that gets soldered down. Once that's there, it'll hold itself. Let's do the USB. Oh, I didn't mention also that USB PD also allows me to put the microcontroller on here and then wire up the microcontroller in a way that I can just plug this in and have a port that feeds this, meaning that I can either use that USB port here to either power it or to actually connect it to a computer for programming. So that's nice. It sucks having to pull the microcontroller off and stuff just to be able to program it. Now, like I said, I'm trying to be more time efficient. I might be a little less chatty than I was last night, but that is only because I'm trying to not screw around so much. Well, that didn't make any sense. Can't cover up the pins and expect to be able to solder them. All right, so should be super quick. Okay, now if you care or notice, I am not forcing the solder on, and I'm also not soldering I'm trying to not just rely on touching the solder directly to the soldering iron. I'm trying to heat up the pin and the pad and then allowing the solder to flow onto that. Now this one, of course, this very first one is the worst possible example of that because that was probably a ground and it was really slow to heat up. But this one should be a little better probably, maybe. We'll see. Also, need a little more accuracy here. You can do it, come on. Heat up. This is interesting. It's actually going really slow, and I've got this thing up to 450. You wouldn't think that it would take that long. Though the ground plane is hefty on this. Yeah, power plane is as well, so I guess that shouldn't be a surprise. Sometimes you do have to get a little bit of solder heated up and just touch the end of it just to kind of help it along because the solder has built-in flux in the middle of it, which helps the solder flow a little faster. So even though you don't want to just, heat it up directly on the soldering iron, doing that to just kind of get it started can help the heat dissipate into the pin a little faster. Okay. And don't worry if these are not fully covered. All we're doing is just anchoring down the pins right now. We don't even care if they're crooked. Very cool. Okay, is that all of them? Oh, we got one more. And yes, I've got a fume extractor that I will be using here momentarily, because this is going to be a lot of solder. All right, so I think I'm going to go ahead and drop in the terminals as well. That one's kind of mucked up. Let's see if it'll fit or not. I think I borrowed that one from my other one, from my other board. We don't need to put that on. Yeah, I can do this. Come on, you can do it. Trying to not let it fall out and not have to tape it, but I think I might have to. Need one more hand. Cool. Okay, there's two. I'm only going to be putting one of these terminals on. The reason is that the battery itself doesn't need to have two terminals. It can both charge and supply voltage from the same terminal. The other one is for, the other big terminal that I have for this is in the event that I want to run power out from this to a battery source to charge that separately. Let's say, for example, I decide that I just don't like having the battery for the guitar, the 9-volt, typically the 9-volt battery for the active pickups on the same circuit as the rest of the board. Well, I want to still be able to power or to maybe charge a battery from there. So let's say I have like a rechargeable 9-volt battery or whatever it ends up being, I can run power out from this to do that. How that is actually going to play out, I'm not sure yet. I haven't really thought it through completely, but I wanted to have the option. Very good. Okay, so yes, these are all kind of here, there, and everywhere, and obviously need to be better laid out, but this is a good start. Now I can take the tape off and work on the thing, I think, you know, soldering really quickly. This is going to get kind of loud. My apologies if it starts screaming in your ear. Hopefully it's not that loud. It's not terrible. So this is a 3D printed fume extractor. I'm on the fence on whether or not it's decent or if it's just a total piece of garbage. That's the way what I've noticed with 3D printed tools, really. Though they're all cool in theory, but in practice, a lot of them just fall flat on their face. What are you gonna do, you know? Okay, so I'm just kind of trying to level these out. Man, that's close right there, but it fits. I mean, I've tested it. So as long as it fits. This here needs to be dropped a little. I'm wondering if the tip on this soldering iron isn't ready for replacing, because it is just a little slow, even with that big ground plane. Too far one way, then too far the other way. I'm just kind of eyeballing this. I really want to get a new video out. I'm dying to record a new one, but I just don't really have the time to crank one out while I'm trying to, you know, do all the super complicated stuff. This takes up so much time, the assembly, testing, and everything, that by the time it's, you know, I need to actually use some of my free time to do some video work, I'm just spent. So hopefully once I get past this stage, I can crank out a new video to show where we left off, because I've made a lot of progress since the last one. It's hard to keep those videos updated on every little step, since I've got a finite time to deliver that information on a YouTube video. Well, I kind of started doing live streaming. It makes it a little easier for me to just casually talk through some of the stuff that's on the design without having to worry too much about time constraints or getting it media ready to where everybody is, you know, wanting you to just crank it out and get to the information as fast as possible. This is kind of nice. Also, selfishly, this totally keeps me on track. I'm about as ADHD as you can possibly get, and just having a somewhat of an audience while I do this stuff keeps me from finding a squirrel to go chase. And that's probably about as good as it's going to get for most of those. This one right here needs realigned, and then we are good. And I am good at chasing the squirrels, that's for sure. This one's giving me a little bit of problem. Ah, too far one way, not far enough. I've found much faster ways to do this kind of stuff. If I'm sitting here by myself and I'm rushing around and I can go grab things without kind of being tied down to the desk. But this is how we're doing this tonight. It's a little bit off. Almost there. I think that having done dozens of these at this point, and I'm probably severely underestimating that I'd be pretty fast at this part, but nope. Dude, work with me here. It's getting stiff because it needs more flux. You know what? I'm gonna call that probably good. I might plug a wire harness in it just to make sure that it works. Yep, nope, that's fine. Same here, that one's good. I'm just looking for the spacing. Yep, that's good. Yep, good there. Cool. Finally. Oh, well, not finally. I guess still gotta deal with these. They're easy though. Need one more here. I feel so spoiled because, I mean, yes, I've been building this stuff up for years, but I really went, not maybe all in, but I stocked up a couple months ago on a lot of my electronic components that I was starting to run low on before the American tariffs really kicked in. So I'm from the Pacific Northwest in America, and now everything is so astronomically expensive, and in some ways just sometimes not even available. So I'm very happy that I did that. Feel like I dodged a bullet. Of course, it's only temporarily. Eventually it's going to come back, and I'm going to have to find a tolerable source for new components, but for now I am in pretty decent shape. It's probably going to be, I mean, there's always some kind of specialty component that you need, but it's probably going to be months before I actually need to purchase anything standard. Okay. All right, I'm getting caught on this, and it's driving me crazy. Let me see if I can bend it out of the way. I never use it. Does that even fit? Oh, it does fit. Side quest. I just don't want to get into a situation where I'm like intricately working and suddenly I catch this here and it kicks the board off of the holder or something like that. Okay, that's good. I know how many times have I said that already. This is where it goes super fast and it's fun. So let's zoom in. Okay. See, this is what I was trying to see earlier, is that the pins just kind of suck up the solder super quick like. Okay. One down. Let's go ahead and get this guy taken care of. This is the terminal for the USB signals on the microcontroller, and I really wish that I would have built-in pogo pins to put on the bottom of the board. I even bought them, but I was kind of in a rush to get this board out. I was really tired of spending time on it just because it's so proprietary. The longer I do this, the more I realize that if I'm going to build something so proprietary, I need to not spend so much time on it that, you know, it's basically, once the project is done, there's no reuse, reusability period. So something like this pogo pins just really started to look daunting when I looked at how much time it was going to take to measure everything and make sure that they were exactly on there, not only just from a XY coordinate, but also a Z coordinate, you know, how high they were, making sure I had the right exact height on the pins. Just too much for a one-off project. So I opted for just a basic terminal instead with with JST connector. And it works exactly the same, it's just not as slick. Maybe if for some reason I end up doing some kind of project where you can see, ooh, that's loose, I need to pay attention to that. As a matter of fact, are those all pushed down? Okay, I got lucky, but I need to be paying more attention, because if those are pushed out and I solder all these down, it's going to be a really bad time having to heat all of that and push it in. Anyway, if I ever get to the point where I do some kind of released version of a board like this, then yeah, sure, I want to make it a little more streamlined and slick, but I gotta stop overcomplicating everything. Okay, this guy's bouncing around a lot, so over here, so I want to kind of help it in and make sure that it's angled right. It's really not, and as a matter of fact, I don't like how this one is, so unfortunately I'm going to have to heat all of these. It's really hot! I'm just trying to ever so slightly move that pin side over here on this side that way. It's doable. But it ain't pretty. You know what? It's just gonna have to stay like that. I don't want to spend all night just slightly nudging this because it's, you know, 1 degree off. Let's move it over here. Sorry, guys. Not paying attention to where my camera is. That looks pretty good. Okay. Just a couple left here. This one's squirrely too. But I like the angle of it, so I'm going to try to go straight up and down so gravity does the work for me. Yeah, I mean, is it ever so slightly sideways? Yeah. Does it really matter? Absolutely not. I mean, it's still gonna drive me absolutely nuts, so. There. There. Can I live with that? You know what? I'm gonna say I can live with that. Okay. I just want to see this thing fired up. That's my big thing, is that I spent so much time not actually playing the guitar, just like revising, redesigning. I've had no time to, other than just some quick tests, to actually pick up the guitar and see it operational. And that's keeping me going. The only other problem here that I keep dealing with is the fact that I've got a couple other projects that I've been dying to work on, and this is, you know, this is perpetually taking my time, so I cannot wait until I can diversify a little bit. But in the meantime, it's not that I don't love this project, it's just been going on for over a year. I would not mind a branch out a bit. Matter of fact, I've already started the projects. I just can't really, you know, formally put together materials on them and show off progress, because I don't want to get in that situation where I've got 4 or 5 projects that are publicly being, you know, unveiled, and then spend, man, this one is not taking the solder, and then not finish the first one, and then that just turns into a mess real quick. Take for granted how big that ground plane is. Ugh, it even makes the soldering iron get stuck to it. I know it looks like it's on there, but I'm still feeling some pull from the plane, so I want to make sure that it's heated and it's really in there. I should have really heated the ground plane a little more before putting the solder on. It's all right though. I think it's this. It's stealing my heat. I think we're good there. And then this one now can really get locked in. And see, that one is just has one trace going right from it, so it's not, it doesn't require, it doesn't suck all that heat away from the iron. I think we're done. I mean, yes, we've got some other terminals, but that's a fan terminal. I mentioned this yesterday. I don't think I'm going to put that on immediately. In early stages on the last version, I put that one on there, and I definitely heard the motor from the fan, and you know, even to that point, the digital signal coming into the guitar pickup. So I don't want to spend a bunch of time testing on a fan and stuff. If it just turns out to be a mess, I'll add it later if I absolutely need it. But that's the one cool thing about doing boards like this, is that I have the option of just testing right now with exactly what I've got built, and I can kind of add in optional features like that in the expansion pins and things like that later on, like this analog here. I know that there's going to be some analog things that I want to add, but I'm not doing anything with that right now, so I don't want to spend the time on it. Okay, enough yammering. Let's get the pins on for the microcontroller. Did I make those too long? No, I did not. They're good. Let's roll out a little bit here. Turn that off for a minute. Man, that's annoying. I just want to get this on just long enough so where I can get a pin soldered down, and once that's done, then I can take the tape off. Oh, you know what? As a matter of fact, the best way that I've found to make sure that these are nicely spaced is to actually put the microcontroller in and solder it like that. Ooh, I have a bent pin. problem with these things is that these microcontrollers are so expensive, but you know, and they get bounced around and pulled and reinstalled dozens and dozens of times, and it really wears on them, and that's unfortunate because of how easy it is to short out something. As much as I think that the concept of a development board like this is really cool, the problem with that is that all these components, they look, because of, you know, they're inexpensive relative to building it out yourself and getting everything tested, but they are not at all resilient to things like excessive voltage spikes and you know, throwing it around and arcing the you know, the ground and positive stuff like that. They are very susceptible to that kind of stuff, and it's so easy to do without realizing it, and before you know it, you burn it out. Now on an Arduino Nano or some kind of little microcontroller, that's not that big of a deal because those things cost a couple bucks at most each. But if you're dealing with something like a Teensy 4.1 like this here, this is the fourth one, I think, or fifth that I've had to purchase in total, not just for this project. I think I burnt 3 of them on this project from the bugs that were on this version right here. But you know, now that I've got that worked out, I'm not so worried about it. But you know, at one point I went as far as to build a extension panel so I could use an Arduino Nano here instead of the Teensy, because I was so terrified of burning these out that here, if I use this and I burn out a Nano, it's not that big of a deal. Or maybe it was a Pico, whatever I used. It was a lot cheaper, point being. All right, so what just happened? So that's interesting. That must have just been attached to that. Okay, that was. So I just had this little IC fall onto my mat here. And this is from one of these when I attempted to repair it, and it was attached to that extender that I just pulled out, or that expander. Oh well. Anyway, so that's good. I just need to lock this down now. Get in there. Oh, so much easier when I've actually got something attached to the pins to help me guide where they should actually sit in the hole. Very cool. Okay, so now I've got those. I can very, very carefully try to pull these out. Hopefully I don't pull any pins or muck it up or anything. I have done that too, because only the those 4 pins are on there, you know, on each side of the headers. Come on. But I don't want to have the microcontroller connected more than necessary while I'm soldering, just in case something goes wonky. I'm terrified to even look at how much these things cost now with those tariffs. I can't even imagine. We're probably looking at $50, $60, $70. Realistically, that wouldn't be surprising. Cool. Okay. That will focus eventually. Hopefully. Cool. Okay, let's get the fan on here. Safety first. And get cranking. like I said earlier, notice that I am not, certainly not, just feeding this right onto the soldering iron. I am feeding it on mostly to the pin and the hole or the plate on the board, because that's where you want the solder to get mechanically bonded. Ugh, I'm so frustrated at this particular session though, because I had plans on really kind of just barreling through and getting everything up and running tonight, and then I go and check my work schedule for tomorrow and find out that I've got a 9 a.m. Pacific meeting, which means that I have to get up early enough to get, you know, into the office and everything, and I have a no meeting before 10 a.m. policy usually. It's just a unusual situation, and that means that I am not going to be able to just go as long as I need to tonight. At some point I'm probably going to have to call it, even if I'm not done. And as of right now, it is 11:46 p.m. and I'm probably going to be able to go as far as like maybe if I'm pushing it 1 a.m., but I got to get to bed after that point. But, you know, hour and 15 minutes, that's probably plenty of time to get some testing done. As you can see, my little makeshift 3D printed fume extractor does decent. It pushes to some carbon filters, which are not sufficient. I am very aware of that, and I am looking at options so I can have much better filtration and even filtration to the outside world. But as of right now, I don't have that done right now, so I just try to not make it a thing where I do too much of this without getting some ventilation in the room. Cool. All right, so I just need to check each one of these pins to make sure that I didn't miss any. That can throw you for a loop, because if it's partially connected and let's say you bump it or something and you don't realize that you didn't solder one of these down, you'll get all kinds of weird signals. This pin is going to be the bane of my existence. What does that even mean, bane of existence? Good Lord. Okay, yeah, everything looks good. Now we get to do some testing. I think we're done soldering for a minute, which is super cool. I'm going to set these aside because I don't need those analog pins yet. Oh my gosh. Okay, that is just fun. Okay, so far, just so you can see comparison, it's very similar, don't get me wrong, but so we had the original, and I'll just spend a couple quick seconds humoring you guys so it's not just me, you know, doing my thing. You can have some context here. Sorry, I'm trying to get it to focus. Focus. Thank you. Okay. So these are the ICs, the motor drivers that control the tuning motors, and those, 2 of the 3 are burnout, and that one is not in good shape. And well, I shouldn't say burnout. I broke the pins on them. That's because I sucked when I was starting this. This is the first time I've done a board with pins that small. I've done some boards like this before, and I've even done some practicing on other boards, but you know, this is not my profession. I'm still just kind of a hobbyist. At least I would consider myself that at this point. But since then, I've got a lot more confident with doing that. but yeah, I mean, I burned a couple of those out, so that's a mess. I've had to do some bug fixing here where I misrouted some stuff or didn't really understand how this very expensive, relatively speaking, very expensive relay worked. And this is the thing that actually turns the guitar on and off via the microcontroller. And then I had to jump these wires here and kind of reroute this a little bit to get this to give me the proper 12 volts. I burned out a couple of those. So I had all these little tiny bugs on this that added up to uncertainty. And then lastly, I had, this one's gonna be kind of hard to see, but I'll see if I can get this at the right angle, but that control board right there, you'll see where it's scratched out. That is because I, unfortunately, had 5 volts running from, or running here to the control board. I didn't need 5 volts. I needed 3.3 volts for like everything on this wire harness. But because of that, I was using 5 volts on those components, which they can accept. But the problem is they were feeding back 5 volts to some of these pins here on the microcontroller. And Teensy microcontrollers are 3.3 volt tolerant. They are not 5 volt tolerant, which I believe is the reason why I burnt so many of them out, because I wasn't realizing that I would connect, you know, this here and everything worked fine until that harness worked and then all the components were connected on the main control board with the screen and the buttons and stuff like that. So because of that, I have now a much more straightforward and streamlined design, so that these pins here all run on 3.3 volts, period, no question. This is fixed, this bug's fixed. Supposedly this bug's fixed. I haven't tested it yet. That's what all these are for. These are for helping me jump and set the, well, some of them are, to set the voltage different. Yeah, so I mean, hopefully we'll get some positive results here. I think what I'm gonna do is let me grab my little mobile here. Let's see, okay, so that's my power supply. I think I'm going to pull this out, and I'll probably start to do what I did last night, where I'm gonna ramp up the power. Start from almost nothing and slowly ramp it up to a reasonable level. And to do that, I just need to get some jumper wires before I turn anything on. And then I'll plug those into this right here, which is where the power comes in, typically when we're running it via USB. We could also do that through the battery, which I'll probably do as well. I mean, this is the whole process of testing, really. Getting a little more comfortable with, you know, the design before you commit to plugging in the microcontroller. So, I've got over here my big drawers of fun. That sounded really bad. Where did I put it? I am looking for the right kind of jumper wires. Ha! Here we go. I think. Yeah, this will do. So I am just going to connect positive and negative on my power supply, drop that on this, probably run about 1.5 volts and start raising it. And then I can just use a multimeter to test to make sure that I'm getting power right and that we're starting to see some LEDs pop up, which last night I was able to at least get some LEDs lit up, and that may sound inconsequential, but in a design this complex, that is pretty monumental to have for one night's worth of work. Pretty cool. All right, so let's jump back over to the overhead. Zoom out here. And we'll see what we got. Okay, let's turn on the power. Actually, I'm on the power supply right now. I'm disconnecting the power, and I'm gonna ramp the voltage down to 1.5. I wish I had a camera on this without turning everything upside down, but you're gonna have to trust me on this one. All right, power is plugged in. We are at 1.5. Now 2. Let's just start with 2. And what I'm trying to do is just make sure that we're getting voltage from here, from the power supply here. So yeah. Let's grab a ground, any ground. We'll use the test ground just to be happy and sure. Really what I expect is that when I touch the 12 volt bus, which is this, I expect to see 2 volts. And it'd be nice if you could actually see it without the reflections. How about that? Yeah, that works. Okay, back to ground. Let's do this one. And then 12 volt bus. Come on. Hey, 2 volts, cool. Okay, ramping up. Now I'm gonna get 3.3 volts. It's possible we might get a lit LED out of this, but it has to go through a lot to get to that point, so maybe not. Nope, nothing yet, but we are getting 3.3 volts, which is excellent. Okay, something's wrong. Okay, hold on. This is interesting. It's not good, and I haven't done anything since last night to cause this, but this will be, whatever is wrong, it'll be interesting to see. So I'm gonna pull out, you're gonna have to deal with me, guys. I am, I'm gonna be holding this camera and it's gonna bounce around a lot, so work with me here. So I've got 2.1 volts right now. Not seeing anything going on here. Problem is that the moment that I get above a certain threshold, I start pulling amperage, and I should not be pulling amperage. There's nothing connected to this board. Oh, there it is. Yeah, see, that's not right. That is concerning because, okay, last night what I did was the only thing I did was I tested to make sure that when I connected power to these same pins right here, that I was able to get these few LEDs to turn on. Now I am, and I mean, these are running maybe 20 milliamps each, if that. Really, probably not even that. So let's talk a maximum 0.4 milliamp, and that was at pushing 12 volts through here. So that doesn't make sense. What I need to do is let's make sure that I didn't cross anything, or I don't have anything connected here that shouldn't be connected. You know, maybe I had some solder that globbed or something. I'm not seeing anything. It's not the end of the world. It's not worth freaking out about, but it's just something that needs to get worked through. I could see these being a point of contention. That's a little concerning, maybe. These, since I had so many problems with the motor drivers, I didn't really get a chance to test them on the last version. Maybe I might bust out my heat infrared camera and see if there's any particular components that are starting to freak out. You know, I think that's probably what I'm going to do. So, yeah, let's do that. In the meantime, I'm going to turn down this voltage. Actually, it was just disconnected because obviously something on this board is pulling amperage that shouldn't. Blah. It was going so good. This is where over time it's been nice that I've built up a little tool set that otherwise I never would. I mean, why would you buy a heat camera and then drop it and break it? Why would you buy a heat camera typically if you don't do stuff like this? You very rarely need to use a camera to see temperature, but thermal imaging is just beautiful when you're trying to troubleshoot. Now, getting this all in camera might be a bit tricky. I hate to mess up my shot here, but I think I'm gonna have to pull this out quite a bit. Okay. Maybe we can go this way. That might work a little better. Yeah, okay. So what I expect, see all those little orange spots, that's reflection, and that's not going to be a big deal. I need to get rid of that second camera. And that reflection doesn't actually equal heat. That's just, it's bright like that because of the reflection. But what I expect to see is that when I plug this in, the voltage, I expect to see something start to heat up. All right, so on my power supply, I've got this plugged in, and I'm turning up 2.1. This is hard because I'm trying to watch everything all at once. 2.6, 2.7, 2.8, 3. I expect it to start pulling amperage here in a second, and we're looking for a component that's heating up. Oh, there we go. What is it? I wanted to say I just saw smoke, but I hope not. Let's pull it back down and just see if there's anything that heated up. I don't see anything. I mean, yes, that capacitor. No, that's just reflections. That's not even that. So strange. All right, going back up again. 3.2, 3.5 volts. Okay, 3.7 volts, I start to get a little bit of amperage. And yes, that you can start to see, okay, that component's heating up a Y. All right, clearly we were seeing, it looks like we were seeing this heat up here and this section heat up. Obviously this is the buck controller or converter. I expect that to heat up a little bit. What we're really looking for is like a big spike, not a, not just like a subtle 2 or 3 degree change. So I am going to raise the voltage again and just hope that I don't burn anything out. All right, 3.5 I think is where it started. Yep, there we go. I've got just enough voltage to start to kick it in. That's interesting. Right there. There's no reason that that should be heating up. That is a terminal. Whoa. Okay. Okay. And yes, I can actually feel that with my finger. It's getting a little warm. So that makes me wonder if this worked so great last time, and I haven't changed anything other than adding these terminals, which are just empty pins that are connected to nothing. And I use the same power that I used, or the same power process or source that I used last night. Why is it now breaking? I mean, I think probably wouldn't hurt to just do a short connection at over 5 volts. That way I can see if these pins are connecting. Or rewind. Oh, pay attention, Chad, to see if these LEDs are turning on. So I'm just going to do that real quick. And they're not. And I'm pulling like 1 amp, so something's wrong. What the heck? Do I have these backwards? No, they're not backwards. Guys, I literally tested this exact same circuit last night and it was successful. Maybe I have a little sliver of metal on one of these pins somewhere. I think what I'm going to do is first I'm going to desolder this right here. This is a fuse, a 0.5 amp fuse. As a matter of fact, considering that I was running for a split second, it jumped to 1.5 amp. I would think that that would have fried if the problem was after the 5 volt rail, because that's what that is. Man, did not expect this. I was thinking that we'd be connecting components before we actually had some kind of amp draw issue or some kind of wires crossed. All right, so let's see, what's the best way to do this? You know what? I'm gonna use hot air. That'll be a little easier. Just gotta wait for that to heat up. This is much less fun than last night. Last night was like, it was just nice, placing components, not a worry in sight. Tonight, it's been just a lot of anxiety. I need to get all these little kinks worked out before I even think about connecting that microcontroller, because the last time that I got overly confident and connected this, it did not end well. So let me pull off this, whoops, and then I break it while I'm trying to fix it. Let me pull off this fuse, which will then allow me to test just the power rails or the power section of the boards. Come on. I purposely undervalued this fuse here at 0.5 amp because I did not want to run into a situation where I was running, like 3 amps through something that was not designed to handle that kind of current. Okay, we'll try it again. I don't think that this is going to actually fail at this stage, because I mean, short of maybe there's something wrong with this chip here and I burned it out, or I've got it, wired wrong in the schematic. But outside of that, there's really nothing that I could see that would go wrong here. So I'm plugging in now. Oh hell, I'll just do this. So I'm plugging in the power supply here. And I'm hoping that I don't end up with amperage. Oh, you know what? It is. It's freaking out. It's saying that it's something's going on from the input here to all the way up until this point here. What that is, I'm not sure yet. I might start tracing backwards and pulling components. This is so unfortunate. When you spend this much time setting stuff like this up, it's just, you never want to have to get to the point where you have to start pulling stuff off, because it's never the same once you do that after you're doing a after you do a reflow job. But it's got to be done. So I think what I'm going to do is I'm just going to get really close to that fuse right here and pull it as quick as possible. Okay, here we go. Just trying to not melt everything around it. There we go. Ooh, that did not come off clean. Alright, I need to make sure that I don't lose track of these. So that one is labeled R, this is 0.5. Okay, those are pretty easy to know what's what. But if it starts to get any more complicated than that, I'm gonna have to start labeling them. Okay, let's plug the power back in. And basically, I'm just gonna start tracing backwards. Oh, yep, and it's still going off. I don't know if that fuse is actually doing anything though in the path. Oh man, I really hope the problem isn't this. I'm trying to think of what the next best approach is here. Do I do something crazy like disconnect the power to the LM2576 and see if I can, or see if it's still a problem, which would tell me we have some kind of crossed line somewhere? Oh, this is so frustrating. You know what? Let me just take a closer look over here, because I did not have this problem last night. If anyone has any suggestions beyond what I'm already obviously testing, I am all ears. And I don't know how well you can see that, but I am looking at this and just nothing at all looks odd. Come on, focus for me. All the pins look solid. I don't see anything that is arching or arcing. I'm really kicking myself for not testing this right before starting. That's the only thing. You know what? Maybe I've got these mixed up on which pin is which. Tell you what I'll do. I'm going to pull the power from a different location. Not that that's going to fix everything, but it might kind of give me a clue as to where the problem is. So I'm just going to take that same power and stick it on where the battery would be supplying power and see if we get the same thing. Oh, you know what? There is no... I got that plugged into where the battery goes, and I'm not getting any amperage there. That could be because of the fuse, though, so I'll put the fuse back on. I'm really surprised that I didn't burn out a fuse with all of this, because I think that I chose these specifically based off of what I expected to be a safe operating voltage, or a safe operating current, I should say. And this is not going to be like a permanent thing. I just want to get it on there enough to test. It's a bummer, because this right here is exactly what caused the other board to turn into a mess, because I had to do a bunch of debugging. I was hoping to just plug it in and it would work, because it did last night. Okay, again, let's test it. So positive to positive, negative to negative. Oh my gosh, it would help if I actually had this plugged in. Okay. You didn't hear that. That may or may not have meant that the last test that I just did was invalid. But whatever. Oh. Okay. Well, that's interesting. So the what? Okay, so that's good. That means that the power from the battery. Okay, so that's okay. I'm gonna see if I can wedge this in just so I can take some measurements here. That'll probably be good enough. Famous last words. What? Why did that work? Okay, so, yep, 5 volts. That's fine. So here's what I'm seeing. Battery, I've got an LED, no problem there. Showing about what I expected to see. Now, over here, I expect nothing, and I get nothing, which is good, because basically this is the input to the USB, and this kind of overrides it. So I guess this is not really that surprising, but up here at the 5 volt, I wonder if I'm getting a proper 5 volt. Okay, I'm gonna go ahead and ramp this up so to emulate the battery at 12 volts, because that's what it's gonna be. The battery that I have is a 12 volt battery for the guitar. Oof, that is a bright battery light now. Interesting. See, I don't know what to make of that either. So I've got no, so what I expect to see here is that the power comes through the buck converter to go from 12 volts to 5 volts. And here it comes to this fuse here, and then it distributes that 5 volts to the rest of the board. But at this fuse, I expect, as long as everything is working properly, for that to read 5 volts right there, and it's reading nothing. So that means I need to trace back to figure out where the last known voltage is coming from. Okay, so that's something right here. I'm getting no voltage across the battery to the buck converter. That's probably because I have all these disconnected here, and that's semi intentional. I I needed to really think through the design here and what I needed to connect and when. So it's not surprising, but that doesn't tell me anything about what's going on up here. So I'm trying to think through what is going to be the best way for me to test to safely step through this area of the circuit. All right, so the battery's working just fine. We need to drop that voltage back down. I'm going to drop it down to, we're drop it super low. We're going to just do like 2 volts. You can see the battery get really dim. So since that is not behaving, when I plug the voltage, or I should say when I plug the power source into what should be the USB power source that feeds the whole board, it's not enough power to actually power anything, but it's enough power for me to check for voltage and figure out, you know, what the path is here and what might be causing this. So we got 2 volts here, good. Oh, you know what? That's interesting. So, trying to think through how this power routes. If I'm getting 2 volts here and 2 volts over here, and I pull that fuse again, what is that fuse actually doing? Let's take a look at the schematic. I'll bring you guys along for that. 1 second. Where are you? There we go. Okay. That is an older version of this. All right, this is the schematic for the latest one. So I'm taking power right from here. It's really close. And I'm pushing it here, up to here. And that's it. I mean, if I'm not connecting this, am I even getting power up to here, to this IC? Thinking. All right, let's start over. So ground right here, we've got this plugged in, and then we've got this plugged in right here. This is a what do you call it? Yeah, solid region. And that solid region is for the 12 volt bus, which comes over here and is connected to this pad right here for testing. Fine, not a big deal. This comes over here. This is connected to this fuse. Now I removed that fuse and we were still tripping the oh my god, my brain's starting to shut down, it's late. The amperage to run away. So I think that means that one of these pins probably on this IC is somehow getting power from that 12-volt bus, which I guess makes sense. What's that plane called? Plus 12V bus. I'm looking for any reference to plus 12V bus. I don't know if I can search that or not. No. That's so strange. VDD. I don't think it's this, because that's something else. Oh, I know what I'll do. No, you know what? That very explicitly only goes to a couple places. That goes to a 1K resistor, which connects, oh, that's where it is. Well, I don't know that that's wrong, but that's how it gets there. So there's a 1K resistor right here. I've got that resistor connected, and that goes dunk, 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 and eventually connects to this IC. Now, if I burned out that IC, I guess I could see where it could possibly... I'm contemplating whether or not the idea of burning out that IC would result in amperage runaway like that. I don't think it would. I think it would just not work. So then the question is, do I just have like a little shaving of metal somewhere that's in between one of these little teeny tiny pins? But like I said, did not have that last night. It was working just fine. But you know what? I had that fuse disconnected and it was still, yeah, I mean, it was still working. Or, I mean, brain shutting down. It was still pulling amperage, and it shouldn't have. So I'm going to pull that fuse again. Let's just get rid of this here. It's probably not smart to be operating with power connected anyway. I'm telling you, man, the sprint that I did last night, I think is just taking a toll on me tonight. I got a lot less gas in the tank. Okay, so fuse is off, and based on that schematic, that we shouldn't see any voltage spike here. But we are, or sorry, amperage spike, but we do. So that's so weird. Connected. Okay, so I've got voltage hooked up, 0 amps. It's at 2 volts. Crank it up to 3 volts, 3.3 volts. Okay, so at 3.3 volts, I'm seeing like 0.8 amps being pulled, 0.08 amps, which is not right. Something on this board. Matter of fact, I need to let it cool down so I can actually test it. But something from here, let me get my little tweezers, from here, maybe up through here, and I'm looking back at the schematic, there's just barely any place where this could be going bad. It's nuts. You know what, for kicks, I think I'm going to, yeah, I think I'm gonna plug this back in, and I'm going to move these just down 1 or 2 pins just to make sure there isn't something funny going with just one of the pins. Basically, I've got 3 different power pins here to carry the load. Nope, all 3 of them. So it's not that. I'll do something weird. Let me see if I can find another ground somewhere to pull from. Come on, you can stretch. Grab the ground from over here. Yep, that's still pulling it. So, I mean, obviously, if all the grounds are interconnected, that's not going to help me at all. What else could cause the problem? Looking back at that schematic. So I disconnected this fuse, which means that this solid region that is the 12-volt bus is, I think that there's something going on with that bus. Maybe I've got something, is there something wrong with the board? Maybe the board's defective? I've never had this. But you can see there's just not much going on here if we trace it. If that fuse is not connected, then that means that if I plug in this pin here and run power, and it runs power, it's only going down to here, to this little test pad. And just to see if I can zoom or show you what it looks like in the real world here. So I doubt we're gonna be able to see it up close like that. Where my finger is right there, that's the test pad. So it's just there. Oh man, this is the time when I need someone that is an electronics engineer of some sort to just kind of stumble in and give some input. There's nothing else connected to that. That should not work. I guess what I can also do is try to connect that pin to 12 volts instead of 12-volt bus, which will basically feed the rest of the board. See if I'm still getting that that odd amperage spike. Let's do that. So basically, just to clarify, the problem here is not the fact that I've got a problem or a bug. It's the fact that it's the equivalent of having a bug that, well, it's like having a problem where you got 2 wires connected that shouldn't be connected, but according to my schematic and everything that I've got laid out here, they shouldn't be connected. There's nothing that is connecting this pin right here that was plugged in on the, oh shoot, I need to switch the camera. So there's nothing that is connecting this pin right here to the rest of the board as long as that fuse is out. Doesn't make sense. Just scratching my brain in the worst possible way. So I think that what I'll do is connect this to a 12-volt source here, and then, so if I've got this connected to 12 volts here, and I've got the ground here connected, then in theory, this is sort of bypassing the bus and taking 12 volts. It should push 12 volts into the buck converter, which would then naturally start to, or it would naturally feed the rest of the system. And you know what? That is not, I'm looking at my power supply, that is not screwing up. So I'm going to add that. So, okay, that right there is the fuse that connects the 5 volt to the from the buck converter to the rest of the system. So if I can get a solid 5 volts out of it goes to this too. If I can get a solid 5 volts out of this 12 volt rail, that means the buck converter is working fine and the problem is localized to this weird bus issue. So I'm going to do the same thing again. I'm going to connect too many things to hold at once. So negative, I just grabbed a negative from anywhere. I got a positive at the 5 volt near where that pin is, or sorry, where the fuse is. And now I'm going to connect this 12 volts, and I expect to see my multimeter read 5 volts. That's the goal. Here we go. Oh, wrong wire. Or not. Well, okay, the wire broke. Let's use the other one. Now, see, this is where it starts to get a little scary. Because now I'm plugging in wires of different colors and I'm going to get mixed up. Well, is it because I have that fuse pulled? No. I really expected that to give me 5 volts. Why would that not? What? Okay, I guess. Oh, well, it would help if I was actually giving it 5 volts. Maybe the power was too low for it to draw from. Oh, wrong one. Okay, so really what I should be giving is 12 volts, but I wanted to start out lower just to make sure that if there was any big whoopsies that I didn't push the full voltage amount. Man, see, I expected to see something there and I'm not getting it, which is sad. That makes me super sad. Bummer. Maybe let me just make sure that I'm seeing 12 volts at the actual, you know what, let's just do this. Am I getting 12 volts coming out of the power supply? No, I'm not, because I have a wire disconnected. Man, I could not tell you how many times I've done that, and that the more I do late night stuff, the more that stuff happens. So we're gonna try this one more time. Now's the time. This is gonna work, right? Not that that's going to help us at all, but we're just gonna connect this, see what happens. Okay, I didn't immediately get LEDs, which is a little interesting. Oh, that's right, because I don't have the fuse in there, so that's expected. Okay, come on, third time's the charm. I hope we got a good solid connection. I'm seeing something, 0.28 volt. That's weird. That could be the result of just a poor connection. So let me make sure that I'm not, like, one of these pins aren't just not quite making contact. So 5 volt. Get rid of this since this wire is broken. All right, back to 5 volt. Ah, heck, we'll just use both of these 2 pins right here to test at that point. I mean, really, I don't see any reason that I wouldn't be getting 5 volts, because I've seen that buck converter works. Saw it last night. What am I doing wrong? Maybe it has something to do with these right here. Let me try to connect at a more direct source. What? What is going on? All right, I guess I'll try to ground over here. Whoa, that was not good. I don't know what happened there. Had a big old spike, and then now I'm not seeing it. Oh man, I hope I didn't just burn something out. I don't know what it could be though. You know what? I was avoiding putting those pins in for the 5 volt, but I think it could be helpful. So I've got 2 little pins that are right here that I can pump 5 volts directly into the board. See, even though I have a lot of debugging to do, I did purposely build in mechanisms like that so I could do that debugging. So I'm just going to grab a couple pins, drop them in here. Man, I gotta go to bed soon, but I would love to at least figure out what's going on before I do that. And burn my finger real quick. Hopefully not too bad. And now I've got something to work with. Cool, so I'll definitely crank down the voltage here to 5 volts on my power supply, which I gotta get a camera over here so you can actually see what I'm doing when I'm changing knobs. I really, as long as I connect that fuse, I expect stuff on the board to come alive. Okay, good. No voltage, which is what I expect. Now, if I just connect that, I'm just really quick, just for a split second, I'm going to connect this directly. And I expect to see some LEDs light up. Okay. Yep. Okay, so that part is working. Nothing wrong with that side of the board. It's all right here. Let's, you know, I should have done something like this right here with a 12 volt. Maybe I can go back to the battery idea. I think I'm gonna get a fresh set of jumper wires, connect them in here at the battery. Oh wait, this is the wrong kind. I'm so organized except for my jumper wires. And the reason is that as soon as I get them organized and I start a project, I tear them all out. So it just feels so futile to even attempt. And then I have to keep tearing off new ones, and then the new ones really shouldn't have been tore off because I've got 24 wires that would have been perfectly fine, but whatever. Let's do this. Let's connect maybe in the battery here. You know what? I'm gonna screw that down. Okay, that's barely screwed down, but better than just not letting it just dangle. I don't know, guys. All right, so we need blue is negative, brown and purple is positive. All right, so we got battery. I wonder if I just do this and connect to this like I did a minute ago, is it going to work right out the gate? And if it does, what does that mean? Like, there's all these questions at this stage. No, it does not. But is that because the voltage is too low? Let's just do slightly higher. No, I think it's because reasons. I haven't really thought through where the power path is going. Let's find out. Let's find out. 1, 2. Nope. Oh, backwards. Not that that matters. So 8. Okay, so power's fine right there. Just kind of curious as I run through these points that have a positive power value. No power at the 12 volt. What does that mean? So the battery, I need to figure out what I don't have connected that that's obviously causing problems. so here's our battery up here. Oh. Do I have that backwards? If I do, then that just simply means that I've got some labeling wrong on the board. What I'm thinking is that I have this terminal in when I might need to have this terminal in. Let's see, how do I have it on the other one? Because these are pretty close in design. It's hard to tell which one I was using because on this one, I've got both terminals in and I mean, whatever. I can connect. So what I'm resisting is connecting this diode on this terminal right here because I wanted to not really add the terminal for having an external power source or power charging option if I didn't actually need it. I just wanted it there in the event that after some time, I realized that I needed to have like a different kind of battery or something like that than what I originally designed it with, but screw it. We can always take it off. Ah! This is why I use hot air. Because it's a nightmare to iron solder SMD components. Okay, I'm gonna assume that that's connected. I hope I have that going the right way. Let me check the schematic one more time. Yeah, it is. We're good. I think. I hope. So let's reconnect. Oh my gosh, I gotta wrap it up. What am I doing? What am I doing? Yes, battery. Battery wire. There you are. I smushed one of these. I can't remember which one it was. I think it's this. Go. Okay, now hopefully when I connect this, this will at least give us something to go on instead of just shooting in the dark, because that's how it feels right now. Okay, so we're pumping 8.6 volts. The voltage doesn't really matter. It's whether or not that voltage is making it to other parts of the board. That's what we're trying to figure out. Making sure that sanity check that I'm connecting proper positive and negative. The battery is on. I see that I'm not pulling any crazy amperage. No big amps. I need to figure out where this voltage is routing. Let's just test 12 volts. Nope. So that still did not. I wonder if this is not really connecting. Yeah, it is. Oh, we got something. What is going on? So I'm getting like a tiny fraction of what I expect to see on the board. So like on the 12-volt rail, I'm getting just a crazy small amount and dropping. That really, to me, feels like there is a, yeah, the drop is concerning. That feels to me like there's a IC going haywire. So I think I'm going to run this again. Where'd you go? There we go. That is the little LED running, but there's nothing that is heating up. I am perplexed. What I'm expecting to find out is that I did something stupid here and I just have something, I disconnected something somewhere along the way. Like maybe like something is not pushed down hard enough or something. So right there, that is the terminal that's got power going in. We're getting a nice little proper battery light, which is good. It's expected. And I'm over here looking at the schematic on my computer. So we right now are connected to this guy right here. You can see the line that goes up to the battery LED, which is right there. And that feeds down to here. This feeds the power rail, which then, where does that go? Did I screw up on this design? I'm wondering, so the 12 volt here, so everything that highlights is just straight 12 volt. And that is what I'm trying to power up right now. I'm wondering how this connects. Oh, I think I see why, because it's on a under layer. That's not bad, it's just this is a 4-layer board, which, you know, obviously creates a little bit of complexity. What? Okay, so we've got all the way over here on the top layer, we should have our 12 volt test pad, which is good. And this line right here feeds to this big solid region. Everything's good there. That solid region then does what with the 12 volts? Like, what I'm concerned about right now is the fact that I'm not seeing how the power, how I designed the power to get from here all the way up over, it's got to jump over to here to feed the rest of the system. So outside of the fact that I've got this weird problem with this one, I mean, I've got these vias which tell me that it's jumping down to another layer and probably exposing it there, but what layer? It might be on the inner layers here, so let me hide these. Oh, wait, there we go. I need a continuity test. I think that's what I need right now. Because there's obviously, I can't imagine that I designed that wrong. That would just be hilarious if I have two completely separated planes for 12 volts and they don't touch in any way, shape, or form. I don't see it happening. And this will tell us right here if that's actually true or not. So this is 12 volts right here, and this is 12 volts. Yeah, see, no, they connect. So no, there's no problem there. That means if I reconnect this, assuming that I've got the diodes facing the right direction, maybe I've got them backwards. I gotta look at that again. Just the craziest stupid problem. Like, that's the second problem that I've had tonight on the power region. And last night, testing the same region worked flawlessly. Let's jump back over to overhead. So, all right, I mean, this is it. If I can't get this now, I'm gonna call it for the night. But what I want to do is see if I can get a voltage read from, let's start here. So here, all right, 8.6. Let's just make it 12 because I'm tired of pussyfooting around with this. Good. 12 volts, that's what we expect. Nice bright battery light, which is good. That means that's working fine. Moving on over here, according to this, I should be able to get 12 volts here as well, or not. Why? Why is that not giving me what I expect? Do I have that wrong? Something's wrong. I'm gonna log into Easy EDA on a couple computers so I can do this a little quicker and not have to jump back over to my main display computer or my main sharing computer just to see the design reference point, you know. Dude, something's wrong. Something's like fundamentally wrong here, because if I can't get, so basically this right here travels from here straight under to this side of the diode. I mean, there's nothing stopping that from occurring, so I should be able to pull. Oh, I am. Okay, 12 volts. That's good. This should be close to 12 volts. This is probably slightly less, just because the diode reduces the overall voltage. Yep, 12.05 volts. That's fine. I'm happy with that. That should move on from there. And really, I mean, there's nothing in between that and the 12 volt right here. Why am I not getting 12 volts here? That doesn't make a lick of sense. What? All right. I'm gonna show why this doesn't make sense. Maybe in showing it, I'll figure out what's wrong. Who knows? But we're gonna bring back all of our layers here. Okay. So 12 volts, if I test these two right here, run a multimeter on those, I get 12 volts just fine. Test it right here, just fine. Test it right here, I think, yeah, that was just fine too. But if I then, you look at this, this comes down here, this is all connected. There's only one via here, but there's no reason that I can think of that that wouldn't be sufficient to come over here to just get a test on this pad. But I'm not getting 12 volts on this pad. What the hell? Unless that pad is just like scarred or something and it's not making good contact. But anyway, so that's what I'm seeing. And now looking at the board, I've got the negative here. Okay, there's my 12 volts. Volts. Okay, so hold on. Oh, that's not making contact. Okay, problem found. Yeah, that makes a lot more sense. I just need to very quickly add a little bit of solder to this spot right here. I'm gonna have to really glob it on there since it looks like it's kind of lifted up. I think that's connected. It looks connected. Okay. Now I should be getting 12 volts all the way over there when I plug this back in. That is a bright LED. Ah! All right, so we got negative here, volts. Yes, thank you. 11.78. I'll accept that. Now I don't expect. Oh, I'm getting. Okay, no, that makes sense, I guess. Does it though? Does it really? Does that make sense? No, it doesn't. Does that mean that I've got 12 volts right here as well? Why? So I've got the USB PD power that should be pushing power in one direction. It should be going just this way up through here and maybe out to the battery. But then that voltage should not be going back into the battery, I don't think. Let me check again. I mean, unless which I don't, unless I have a faulty, unless this diode is faulty, this should be preventing the voltage from coming in here, going out here, and then going in here, and then going back out over to this. But it's not. Why? When you get into multiple sources of power, running power, so if I've got like a battery and then I've got a charger that you want to be able to run the system off of while you're charging, stuff like that, that's where power routing becomes very important. So you use things like diodes and ways to push power in one direction so you don't have backfed power to to another system. That's what these diodes are for. Now it's supposed to allow the flow of power to come through here to the main 12 volt rail, and then the 12 volt rail blocks it from coming here because that diode should stop it. I wonder if this diode is reading. I mean, no, it's fine. Yeah. See, that open lead tells me that the diode is doing its job. Maybe there's something else somewhere that is allowing power to flow. Or maybe the problem that I'm having earlier has something to do with this. So when I was plugging it in earlier directly to the USB PD to just see if the power rail right there was working, that's when I was seeing some weird amperage pull that I shouldn't have been seeing. So now that I'm doing this, I'm seeing the power is leaking over to this pin right here, which makes me think that something somewhere here is touching that should not be touching. I mean, that's the theory at least. Maybe I'll bust out the microscope. Sorry guys, I'm just trying to get it situated here. I want to look at that IC that I've got. Get it in focus. I'm looking for like a metal shard or something. Super clean. Doesn't really look like there's anything wrong. Oh, that light shining. It's making it hard to see. I'm trying to focus while I'm doing this. Huh. Maybe I know I had to separate those pins. Maybe there's something there. Let me get a scalpel or a X-Acto knife on that just to make sure that there's nothing, some kind of residual junk. I don't know if that has anything to do with this, but I just want to make sure that that's absolutely not a factor. I don't think so. I mean, it feels pretty clean. You know what I can do is just continuity check those. So I'm going to, where was I? Oh yeah, check these two teeny tiny little pins here. I'd have to look at the data sheet to figure out what those pins are, but either way, I'm sure they shouldn't be touching. Okay, and I might as well, just while I'm at it, test the rest of them. That one looks fine. These are really small, so I need some extenders on my multimeter so I can test a little more carefully. I've stabbed myself so many times with these things. Okay, so I think I'm just going to test each pin next to each other. See, putting those together should get 0. If any of these read 0 together, then I know I've got something touching that shouldn't. Which is probably where I should have started to begin with. That's fine. Super high resistance just tells me that there's some kind of interaction between those pins. That doesn't mean that they are actually touching. Just the IC has some kind of circuitry where they're involved in each other. Ooh, this is tiny. I'm trying to do this where you guys can see the multimeter too, not just me. Oh, what is this? I think it was just touching them together. Yeah. Nothing wrong there. I don't see anything here where these pins are crossing. I just don't know. Okay, guys, I think I'm gonna have to call it for the night, even though I am one of those people that just cannot leave it alone when, you know, I've got an outstanding issue that I know needs to be dealt with before I get, you know, on with the rest of the project. Schedule is gonna just not permit me to continue. So I'm gonna have to pick this up. I'm gonna try to figure this out off camera so I'm not just dragging down the streams with some stupid bugs that are probably I connected a wire backwards somewhere. So I'm gonna try to get that taken care of. As soon as I can get that done, I will schedule another live stream so I can finish the assembly of this and get it working. Hopefully get a guitar plugged into it so I can actually see some signals get routed and make sure everything else works. Until then, you know how to find me here on YouTube. You can find me on Instagram at MetalheadMakerChad, and I will see you guys pretty soon. If you have any questions, of course, leave them down in the comments of this video here, and hopefully by the time I show up next, I will have this taken care of. All right, guys. Take care, peace, stay safe, don't pay too much in taxes with all these tariffs. All right.